So doubts related to topic circular motion. The question were question 9, question 12 part B, question 18, and question 24. So starting with question 9. So starting with question 9. So starting with question 9. In this question, a car of mass M drives over a circular humpback bridge of radius r with a constant speed v. When it is at top of the bridge, the force on the car from the bridge is given by. So we need the force on the car from the bridge. We need the normal contact force, or R. So the normal contact force R is acting upward and weight of the car is acting downward. And the result of these two, will give us a resultant force, and that resultant force will be the centripetal force, which will direct towards the center. So we can say the centripetal force in this case will be equal to weight minus the normal contact force. Why weight minus the normal contact force? Because as it is moving in a circular track or a path, so the resultant force must be towards the center. So to create a resultant force towards the center, the weight should be more than R. We need the value of R. So if R move other side and centripetal move force, so R move other side and centripetal force toward the right hand side. So we can say the normal contact force is equals to weight minus the centripetal force. What about the weight? Weight is given by a formula mg. And what about the centripetal force? Centripetal force is given by a formula mv square over r. So the normal contact force, the force on the car from the bridge, is given by mg minus mv square over r. So it matches with option D. The next question is question 12. This is question 12. The steam engine can have their speed controlled by a device as shown in the photograph. A simplified diagram on the device is shown on the right hand side. The two steel balls are there, each of mass M, can move apart at the end of a lever, and they are free to move and pivoted. As the vertical shaft rotates, the two steel balls move apart so that the angle between the lever and the vertical, that is theta. This action is linked to a valve that reduces the flow of a steam, reducing the speed of the engine. Complete a free body force diagram. Free body force diagram represent all the forces acting. So one will be the tension. If we are drawing for the left hand side steel ball, because we want to draw for one of the steel ball. So if we are drawing from the left hand side, then this will be tension and weight will act downward. If you are using a right hand, then the weight will act downward and the tension will be there. The next part, the shaft is rotating at 62 revolutions per minute. So 62 revolutions is complete in a minute. We have to calculate angle theta, where mass of the ball is 5.1 and the length of this arm is 270 millimeters. So we have to convert into meter. Now what happened? Like, look, first thing, we will get the value for omega. How to work out the value of omega? omega is equals to the value of the omega is equals to 2 pi divided by, or omega is equals to theta divided by t. So omega is equals to theta divided by t. How many revolutions are there? 62 revolution, but we have to convert it to pi radian. So 62 multiplied by 2 pi. So that will be radian. And time should be in second because of omega should be in radian per second. So 1 minute is equals to 60 seconds. So we will divide it by 60. So 62 multiplied by 2 pi divided by 60 will give us the value for omega. And after getting the value for omega, now what we will do, like this is the value of omega. Now we have to use the figure to work out the component of the tension balancing with the weight. Like here, this is a tension T and the weight is acting down. So this is tension T and weight is acting. So the tension will have two components. One of the component of a tension is with an angle. So the component of the tension which is with an angle, that is T cos theta. So this will be T cos theta, T cosine theta, this one, which is upward. And against the angle will be T sine theta. So against the angle is T sine theta and with an angle is T cos theta. So when we resolve this, like when we compare, this one is T sine theta. So T sine theta is directed towards the center. It means T sine theta is responsible for the circular motion as the center, like it is directed towards the center. So we can say the centripetal force is equals to T sine theta. So centripetal force is equals to T sine theta. And what about the cosine theta? Because T cos theta is acting upward and weight is acting downward. So weight will balance with the T cos theta. So T cos theta will be equal to weight. Now we will simplify. The centripetal force is T sine theta and the weight, vertical force is T cos theta, balances with the weight. If we divide the two equations, so T will cancel with T. And what about the centripetal force? Like this FC. The centripetal force, if I use the first equation, so centripetal force is given by mr omega square is equals to T sine theta. That's from first equation. And the second one, which is weight equals to T cos theta. So weight is equals to mg. So mg is equals to T cos theta. Now, if I divide these two equations, when I divide, like if I say this is my first equation and this is the second equation. So if I divide these two equations, so if I divide the two equations, mr omega square divided by mg is equals to T sine theta divided by T cos theta. So this T will cancel with T, M will cancel with M. So we are left with R omega square G is equals to sine theta over cos theta is tangent theta. So that is equals to tan theta. Now we have the omega from the beginning. We have the value of gravity, which is 9.81. But what about R, the radius? So how to work out the radius? If we know the length, like this total is L. So again, the component will be there. The component of the, because this will be the radius R. So the component of the length, which is against the angle, this will be L sine theta. So we can substitute R is equals to L sine theta. L is there. Or if I further simplify this equation, like till this point, when we solve, even if I don't change to tangent theta, I can say R omega square over G is equals to sine theta over cos theta. Now, we know R is equals to L sine theta, that is against the angle. So in place of R, I can write L sine theta. So this will be equal to L sine theta omega square G is equals to sine theta over cosine theta. So we'll simplify. Sine theta will cancel with sine theta. We have now the cosine theta like cross multiply. So cos theta will be equal to G will be multiplied there, and L and omega square will be divided. So we have the G, we have L omega square, and at the last we'll take theta is equals to cos inverse of this G, L and omega square. We'll get the value for theta that will be in degrees. Is it clear, this part, question 12, part B? How we work out the angle? The next is question number 18, part B. So in question 18, first part A, the student holds a piece of a string with a small spherical mass attached to the other end. He rotates the mass at a constant angular velocity in a horizontal circular path. So what will happen? The weight will be there that is acting downward, and the tension, as we did the similar question down, that was 12 part B. So this will be the tension, T will be there, and this tension will have two component theta. If the vertical, so the one which is with an angle, that will be T cos theta, which balances with the weight, and against will be T sin theta. So T sin theta is responsible for circular motion, and T cos theta must balance with the weight. T cos theta, T cos theta must balance with the weight so that the object can move in a circular path as well as it will remain in a vertical position as well. So explain why it is not possible for a student to rotate the mass so that the string is horizontal. Like why student cannot rotate like this? If a student is holding, why student cannot rotate this in a horizontal circle, but like horizontal path is there, but also it is having a vertical component. So what is the reason for that? The reason remains the same, because there is a weight which is acting downward. So there must be a component of a tension which balance with the weight. That's why this can never move in a horizontal circle. If this object was like weightlessness, like condition was there, like it was not having any weight, no downward force, in that case, this object can be rotated in a circular path, horizontal circular path. But because the weight, there is a weight of an object, so there must be a component of a tension which balances with the weight. That's why it cannot move in a overall horizontal path. The part B, the student now rotate the mass in a vertical plane. Now he's rotating in a vertical plane. As you can see, different positions are there. The string is having a length of 25 centimeter and it is attached to a mass of 204 grams. It is rotated in a vertical circle with a string remain taut at all time. When the mass is at the top of a circle, it moves. So we have to calculate the tension here. Okay, part B. I was discussing the whole question. That's why I was just going through the whole question as I need for the next part. So we need the tension here. So when the mass is at the top of the circle, it moves with the angular velocity. So if the mass is there at the top of the circle, so weight is already acting downward. And because we are holding it by a string or a wire, so there must be a tension. And the result of the two will give us a centripetal force. So means the centripetal force, the force which is directed toward the center, is actually weight plus the tension. So if we need the tension here, that will be the centripetal force minus the weight, will give us the tension. And centripetal force is mr omega square. Centripetal force is equals to mr omega square, and the weight is equals to mass into gravity. So we'll substitute the values. The mass is equals to gram is given. We have to convert into kilogram. So it will be 0.204 multiplied by the radius, 0.25 multiplied by the omega, which is 9.9, and then square will be there, minus mass is there 0.204, and in the gravity 9.81. So when we substitute, this will give us the value of a tension, which is about 3 Newton. Now, this value of the tension will change, will vary. And when we solve, the centripetal force must be constant. Like the centripetal force in this case, when we calculate F is equals to mr omega square. So this part is a centripetal force. And how much is this? This is 5, and the weight is equals to 2. So 5 minus 2 equals to 3. So means all the positions, we need the centripetal force to be 5 Newton. When it is at position A, when it is at position B, when it is at position C, and when it is at position D. We need all the cases. We need the centripetal force to be 5 Newton. This will be 5 Newton. This will we want 5 Newton. This we want 5 Newton, and this we want 5 Newton. Because the centripetal force, all the cases must be equal to 5 Newton. But what happened here in this case, if the weight is equals to 2 Newton, how much should be the tension? That should be 3, because 2 plus 3 will make it 5. But at position C, the weight is acting downward. If the weight is acting downward, weight is of 2 Newton, which is acting down. So how much the tension should be there to create a resultant of 5? So the tension must be 7 Newton. So there must be a 7 Newton tension, so that it will create a resultant force of 5 Newton towards the center. And B and D are not affected by the weight, even it is 2 Newton, but it is not affected. So we need 5 Newton and 5. So here 5 Newton centripetal, here 5 Newton centripetal, here also 5, here also 5. All the cases 5 Newton is a centripetal force, but the tension will vary at position A because the weight is contributing towards the centripetal force. So we need a small tension. But at position C, the weight is opposite to the direction of the centripetal. So as a result, we are direction opposite to the tension. So we need a greater tension force. So at position A, the tension is minimum, which is 3, but at position C, the tension will be maximum, that is 7. So as a student completes one circuit, vertical positions are there. So on the axis, sketch how the tension in the string varies and complete a 4 circle from A. So from A, example, if these are the values we plot. So when it is at position A, what was the tension? Because all the cases, like we say, this is position A, this one is position B, this one is position C, and position D. So all the cases, we want the centripetal force to be 5 Newton. So all the positions, we need centripetal to be 5. The weight is acting down here. So weight is already contributing 2 Newton. So we need tension to be 3. So at position A, we need a 3 Newton tension. At position here, this is a tension. The centripetal force is a tension. The weight which is acting down does not affect the tension. So at position B, when it rotated 90 degree, it will be 5 Newton. Then when we move to position C, the weight is acting downward. So as a result, when the weight is acting down, and we want the resultant to be 5 Newton. So here the weight of 2 Newton is acting down. So we want the resultant force of a 5 Newton. So how much tension should be applied? The tension should be 7 Newton upward. So 7 up and 2 down. As a result, it will create a 5 Newton. So 7 minus 2 will make it 5 Newton. So this will be at 180, it will be equals to, the tension will be equal to 7. Centripetal is 5, but the tension will be equal to 7. Then at position D, which is angle of 270, because 90, 180, 270, again it will be 5 Newton. And when it returned back, it will be 3 Newton. So this is the sketch how the tension in a string vary for an object moving in a circular path at a vertical circle. Is it clear, this one? Then the next question is question 18. This was 18B, 1 and 2. The next question is 24. 24. So in this question, question 24, so the highest roller coaster in the world in 2007, which is Kingda K, a train is initially propelled along a horizontal track. So initially what happened, the train is moving horizontally, then it rise, like there's a slight bend, and then it will rise to a maximum height, and then it come down. So a train initially propelled along a horizontal track by a hydraulic system, it reaches a speed of 57 from rest in 3.5 seconds. So at this position, it reaches a speed of 57 meter per second when it starts from rest, and the duration for this one is 3.5 seconds. Calculate the average force used to accelerate a fully loaded train along a horizontal track. So we need the resultant force. We have F is formula F equals ma. Force is equals to mass multiplied by acceleration. Acceleration of an object, that is the change in the speed divided by time interval. So initially it was at rest. Initially it was at rest, then it reached a speed of 57 meter per second and 3.5 seconds. So A equals V minus U over T. So 57 minus 0 divided by 3.5. This will give us the initial acceleration of the train. And after getting the initial acceleration, we'll multiply by the mass. So it will be 57. So F equals ma. So 12,000, which is a mass, multiplied by acceleration 57 divided by 3.5. So when we multiply, we'll get the value for F, that is in Newton, which is about 200,000 newtons. That's a force. The next part at point X is just before a train leaves the horizontal track and move to a first bend. Complete a free body force diagram to show the two forces acting. So the two forces acting in this case, like if a driver is there on the horizontal track, so one is a weight of a person which will act downward, and the other one is a normal contact force which will act upward. So the two forces which will act here on the person when he's sitting, his weight will act downward, and the normal contact force from the seat will act upward. So you have to label as R and W. In part C, the mass of a rider is m and acceleration is g. Just after point X, the normal contact force from the reaction force of the train on the rider is 4 mg and can be assumed as a vertical with reference to as a g force. So 4g is the force. Show that the radius of a track is about 100 meters. So how we can show this? So the idea is that when the train is moving in a circular path, so there must be a resultant force which is acting toward the center. So at this point, the normal contact force is 4 mg and weight is equals to, weight is downward, normal contact force is more than the weight, and normal contact force is 4 mg and weight is equals to mg. This will create a resultant force, a centripetal force. So centripetal force in this case equals to R minus W, or the normal contact force minus the weight. R is equals to 4 mg minus mg is equals to centripetal force. So 3 mg is equals to centripetal force. And what about the centripetal force? The centripetal force is given by a formula mv square over R. So mv square over R is equals to 3 mg. Now when we simplify this equation, m will cancel with m. We need the radius. So if we need the radius, it will be v square over 3g is equals to R. So v square over 3g is equals to R, where v is the speed at which the train was approaching or moving, that is 57. So we will have 57 square divided by 3 and the gravity 9.81. So when we simplify, this will give us the value of the radius, which is about 110 meters, which is approximately equal to 100 meters. So the radius of this curved path X is about 110 meter. This curved part, this part. This is for point X. Is it clear? Is it clear, the first part? The radius of the curved path at point X, which is about 110. Then we have the next part in which we have to show that the speed of the train as it reached the top of the vertical tower is about 20 meters per second. Assume that the height of the vertical tower is 139 meters. So height of this tower or height of the tower is about 139 meters. So what happened? The initial kinetic, because it is still moving. So if it is still moving, so what is the initial energy? The initial energy is the kinetic energy. But when it reaches this point, it's still moving, it does not stop. So it will have a kinetic energy plus potential energy. So if this is kinetic energy 1, this will be kinetic energy 2. So kinetic energy 1 is equals to kinetic energy 2 plus potential energy. So we can say the kinetic energy 1 is equals to the potential energy plus the kinetic energy 2. Kinetic energy is half mv square, so I can write 0.5 mv square. Potential energy is mgh, and again kinetic energy is half mv square. But these two velocities are different. The velocity here v1 was 57, and we are finding the velocity at position y. So that is we call v2. M is common in all the three quantities, so we cancel out. So equal to 0.5 v1 square equals to gh plus 0.5 v2 square. Or when we simplify, so 0.5 v1 square minus gh is equals to 0.5 v2 square. So 0.5 multiplied by speed that was 57 square minus the gravity is 9.81 multiplied by the height 139. That is 0.5 V2 square. What's the answer for this? 0.5 into 57 square minus 9.81 into 139. When you simplify, what's the answer for this part? So that is 260.91 is equals to 0.5 V2 square. Then 0.5 is multiplied, other side will be divided, so it will be 260.91 divided by 0.5 is equals to V2 square. When we divide by half, it will be double, so it will be 520, 520 about 520 and take a root. What's the answer for under root 520? What's the answer for under root of 520? 22.8. So the final answer for the speed will be 22.80 meter per second. That's the speed. That is the speed at which this will reach the top. The next part, the rider will feel momentarily the weightless if the vertical reaction force becomes zero. The track is designed so that this happen at point Y. Calculate the radius of the track at point Y. So what will be the radius of the track at point Y? Because at this point, they say the normal contact force is zero. So R is zero. So the only force which is acting is a weight. And weight is, so weight is a centripetal force in this case. So F is equals to W. F is equals to mr omega square and W is equals to mg. So M will cancel with M. Or we can also use, because we don't have the omega, so I can use F is equals to mv square over R is equals to mg. M will cancel with M. So if we need v square over g will be equal to R, where v is the speed at which it was moving in the track, that we worked out it was 2.8. So 22.8 square divided by 9.81. That will give us the radius. What's the answer for this? 22.81 divided by 9.81. This will give us the radius of the track at point Y. What's the answer for this? So that is 53 meters. The radius of this part is about 53 meters. So this R equals to 53 meters. And there's one more doubt, which is about 19 part B. This is how the value of theta can be determined experimentally. So how we can work out, how we can find the value of the theta experimentally. So if experimentally, if we want to determine the value of the theta, so we have this radius, like example, what we can use, we have the formula S is equals to R theta. Or what we can do, We can measure the length, and we have the radius. Practically, like if we have this radius R is there, and we measure the length. So we want to determine the theta. So according to this is making a right angle triangle. If this is making a right angle triangle and this is our angle, so this will be the base, this is the hypotenuse, and this one is a perpendicular. So if we have the hypotenuse and perpendicular, we can use a sine theta. So sine theta is perpendicular divided by hypotenuse, or theta is equals to sine inverse perpendicular divided by hypotenuse. So what we'll do, we'll measure the length of the string by using a meter rule or a meter scale, and we'll determine the distance from a mean position to get the radius, and length divided by radius. Taking the sine inverse of this, we will get the value for theta. Is it clear, this part? How to determine the value for theta? So these are the doubts related to topic circular motion.